and welcome to the SquaMates podcast. This is a very serious podcast about reptiles and amphibians, and I am one of your four co-hosts. My name is Dr. Mark T. Schertz. I am the curator for herpetology at the Natural History Museum, Denmark, and I'm joined today by my three lovely co-hosts, as ever, Hirol Naik.
Hi, I'm Hirol, a snake ecologist and conservationist from South Africa.
Dr. Hirol, I forget every time now. Good, excellent. And Ethan Kosak.
Hi, I'm Ethan. I'm a artist, illustrator, reptile enthusiast, and general layabout.
And Gabriel Lughetto.
And I'm Gabriel Lughetto, and I'm a paleo artist, scientific illustrator, concept artist, and I used to work in herpetology, but not anymore.
So, Gabriel, you've got some big news, right?
Yes, a couple of them. The first one is that it was revealed that I am one of the concept artists that did a lot of concept arts for an upcoming NBC Universal docuseries that is called Surviving Earth. They just shared my concept art of a baby Spinosaurus. I also did the adult
cute.
Spinosaurus. Yeah. Thank you. It was super cool working on that project. I cannot say much more than that, but I'm sure that the series will premiere next year, and I am sure that I'll be telling you more as the time goes nearer to premiere.
How many designs have you been involved in?
I cannot say yet. I cannot say anything else yet, but that.
Is it a fraction larger than one? Smaller than one. I mean, it is not all of them. It is not a Gabriel-only production.
No. They just released actually another concept art of a Smilodon by the legendary paleo artist Mauricio Anton, which does an amazing job with, he's the guy to go for, prehistoric felines and stuff like that. So
wicked.
Really, really cool. There are some other really good paleo artists involved in the project. So really excited about it. And then the second news is that yesterday, when we're recording this, the amazing, really cool new reptile was published. And I was lucky enough to be commissioned to do the
new Drepanosaur just dropped.
Yeah.
Yes, new Drepanosaur. Now we know they're Drepanosaurs. It's an animal that is called Mirasaurus, and is the sister taxon to a very enigmatic species that we didn't know much about before, which is Longisquama, which is this amazing reptile with really long plumes on top of its body.
Truly bizarre creatures.
Until now, we didn't know what Longisquamas fit in the reptile tree. But now...
And I think we actually talked about Longisquama in the chameleon episode, so about 2 episodes ago, where we were talking about how Drepanosaurs are not exactly very good models for chameleons. They have these weird adaptations. I think Longisquama is the one that has a massive claw on the back of the tail, right? Or is it a
No.
Those are different.
Those are Drepanosaurus and Megalonchosaurus. Those are derived Drepanosaurids have a claw at the end. But Longisquama, no, we don't know actually what we don't know what the posterior side of Longisquama looks like. We only have the anterior half of Longisquama. But now with this new species, with Mirasaurus, we have over 80 specimens. No, I think over 70 specimens, which is crazy. And a lot of them are beautifully preserved. They were collected in the 1930s to be crazy. It's crazy. They're from formation from the middle Triassic, so they're older than Drepanosaurids. A middle Triassic formation in France. And they are just, it's an amazing creature. And the cool
what a
thing
bizarre
about them,
animal.
Yes, they truly are. For many reasons, taking aside the fact that they had a crest of plumes on the back of their backs, like more derived Drepanosaurids, Mirasaurus had a bird-like skull, and it even have like an edentulous anterior part of their skull, which it doesn't seem to have had a beak, but it was still very beak-like. And so to start with, that they are bizarre in that sense. And then on top of that, the plumes are not homologous with feathers. But they are similar in the sense that the fossil preserved these feathers. The fossils preserve melanosomes in these feathers, and the crazy things in this plume, not feathers. I keep saying feathers, but the melanosome structure in these plumes is similar to feathers. So that's really interesting, and they are not feathers because, unlike feathers, they do have a central vein like feathers, but they don't have filaments coming out of that vein. It's just a plate that comes out of the vein. So also the crest is not the one each behind the other. They are like intercalated, like on one side only. So it's not like they are.
That's the weird thing to me. It's like they're left or right-handed.
They're asymmetric. Yeah, they're asymmetric.
Why? It's so weird.
It's got to be a display. It's got to be a display thing.
Some kind of folding mechanism.
Yeah.
But is there any flexibility in these things? Always the body, it's basically always at a right angle to the back, right? So there doesn't seem to be any flexibility in this structure.
I don't think that has been studied deeply, but when I asked Stefan Spiker, the lead author, Stefan Spiekman, the lead author of the paper, when I was doing the reconstruction and asked him, well, are we going to show this as a folding structure? He said, no, we cannot, because first of all the preserved specimens that preserve the crest have it in the same position. And it doesn't seem, there's not like an obvious hinge structure or anything that indicates that this thing was moving. So maybe it was moving, but we don't know.
Connection with the back at all. Like it's just like thunk.
No, but the thing that really piqued my attention is that, you know how, well, for the few of you guys that know what trypanosaur skeletons look like, they tend to have like a hump on the top.
Yeah.
Mm-hmm.
And this animal also has a little hump. And I wonder if these structures are present in all trypanosaurs. Mm-hmm. Which it would be crazy, because they would make him even crazier looking, as if they were not crazier looking
why
enough.
Is it so short? It's such a small fraction of the back. Like it's a very distressing animal to me. I genuinely had a hard time sleeping last night because I was like, it looks wrong. It has to be wrong. Something is so weird here. The face is bizarre. Trypanosaurs already were strange. That's a weird reptile. Like, what are you doing?
I think we talked about trypanosaurs once before. I think they've come up several times with us, because I think we mentioned them with that preserved in amber specimen where
for oculodentavis.
Yeah. Yes. And it had a beak like thing, and we were like, okay, well, trypanosaur. You're right in that it's one of those creatures that sevens of nerds know about, but Longisquama is the one that I like. That this is one I've not actually ever heard of Mirasaurus until yesterday. As far as
it didn't exist until yesterday.
Well, it didn't exist until yesterday.
Well, anything like that. I didn't know that there was anything in the works or whatever. But I made the joke yesterday that we can finally put to rest the idea that Longisquama is just several lizards that died on several ferns. And the fact that was an actual serious hypothesis about these creatures shows you, I think, how insane they are.
There are many things being proposed. For a long time, it was thought that Longisquama had two sets of these things that went sideways, and that it was a flying animal that used.
That it was flying. It's in Disney's Dinosaur. It's shown as a flying animal.
Yeah,
I think it's the only. They said that's the only time it's
too. They also show it as a flying animal.
Incredible.
But no, they were just doing, and we proposed that, or the authors of the paper proposed that they were using this as a communication of some sort.
Like a nollies and dewlaps.
Yeah.
I would say,
Sure. I mean, I think that to some extent, no structure that develops like this can not have a role in communication. You wouldn't just have a bland colored massive spike off the side of your body.
Yeah.
Right. It's a reptile. Like visual signals is very big in the reptile group. So it feels like, you're gonna wind up with some kind of structures
if
that are
derived Drepanosaurids had these structures as well.
Yeah.
I want you to visualize this in your mind, because this would be an animal that has a crazy giant claw on the top of its hand, a bird-like beak with no teeth, forward-facing eyes, a tail that has a claw at the end, but can only be it's not conventionally prehensile, because it only moves that way, and it's actually quite rigid,
like a hinge.
So it's like for anchoring themselves on somewhere. Opposable feet, so it's just a crazy.
It's obviously an anteater. Like it's gotta be an anteater. It's gotta be an anteater.
You've got some anteater-like features, sure.
It's got a lot of anteater-like features.
I was thinking pollinator, like nectar eater.
Oh no! What are you doing with the claws if you're a nectar eater? Very weird.
Yeah.
Maybe there were fruit around that it was like whacking its face into it.
And previous Drepanosaurids, like Megalonchosaurus, didn't have the claw, but they had like chameleon hands. Yeah. So they have even been proposed to be grabbing prey with those hands. So they're just insane animals, and they are one of the coolest.
They're so science fiction. Like,
what if it's a parasite? What if it's a parasite? It could be a.
They're so small. Holy shit! Let's talk about how small Mirasaurus is, because I thought from the illustration this is like an iguana-sized lizard.
Yeah,
it's tiny.
Yeah, they're that's why they're perched on fern fronts in that illustration.
Right. Yeah. I mean, tree ferns are pretty strong, but
I forgot the species of fern because that is an actual species of fern that's been preserved in the same locality. I forgot what the name of the genus is. So that's why we wanted it to be on top of those ferns.
So following up on that, what is the size? It's
they're
probably 10 centimeters, 15 centimeters.
10 centimeters? And then they've got this ludicrous thing on their back. And how big were the biggest Drepanosaurs?
About 50 centimeters. Like Drepanosaurus is the largest, and it's like about 50 centimeters. But it's a much more robust animal. Is compared to Mirasaurus, Drepanosaurus is very robust. The tail of Drepanosaurus is thick. It's a robust.
See, that makes sense as an anteater, but one of these piddly little things, and we've got so many fossils. So these, this is a good representation of the approximate adult size, probably, of these animals. And it's just, it's unbelievable how small they are, which kind of does away with, I think, pollinators back on the table.
and Squama is not much larger. It's a little bit larger, but not much larger.
So now I'm thinking parasite. It's like a tick. It hides in the ferns. It uses the sail as camouflage in the plant, to look like foliage.
I don't understand why the size is surprising you guys. I mean, it's very lizard. I would imagine there were a lot of lizard-like things.
Yeah.
It's just that these things look so much like sloths / an early attempt at a therizinosaur. So
I imagine these things. Where I imagine walking through a fern forest and just seeing these things perched, several of them perched on forest, showing these things and probably moving them in angles to catch the light.
Uh-huh.
And I think that probably, to me, first it sounds very natural, but also very alien, bizarre, which is awesome because that's what the Triassic was mostly. The Triassic would have like that completely.
Yeah. But one thing that occurred to me, the fact that these things, they do go across each other in this nicely stacked way. And in our, day-to-day, if you're you may have worked with, a collapsing fan. And one of the fun things about a collapsing fan is that if they don't have membrane in between them, you can blow on them at a certain angle and they'll whistle. So you could also have acoustics going in and be like, and if they overlapped in like left, right, left, right, left, right, there would be a total wind block from them. They would be sealed. But if they are in a series, they're actually not a wind block at all, because if they're slightly flexible, the wind can kind of go through them, so it's not going to blow the animal off the plant.
Well, yeah, and also I was thinking that I wonder if they had the possibility to arrange them, to move them from interlocking in one position or another, because I depicted them interlocking the same position in both angles. So I was imagining that there were like some left-handed and some right-handed specimens, which makes sense they would have been. I mean, because I doubt that this structure grew the same in every specimen.
Mm-hmm.
You know what I mean?
Yeah.
So
Sure.
I think that we're just scratching, the surface with the things.
So, Gabriel, is this one of the weirdos that you were rumoring about in previous episodes?
This is the one
The weirdo
that I was.
Yeah. Well,
the weirdo.
you were right. It's weird, and I don't like it. Like, I love it. It's my new friend, but it's so weird. It's so weird. It's just so weird.
Yeah, it's definitely not a flying animal. We can probably put that one to rest. Like,
Yeah, no,
that
it's
makes me
not
think of like
but Avatar.
Oh, I thought you were gonna. I was gonna say. It makes me think of like the guys who thought Stegosaurus was flapping the plates.
Oh.
That was,
Yeah. I mean, okay, these are weird. This is an episode about dead things. And I mean that sincerely, because our actual topic, the actual reason you're here, dear listener, is to hear us talk about some SquaMates, but dead ones. So we're going to talk about Mosasaurs. And I mean, Mosasaurs are not as cool as Trypanosaurs. I think we can agree, but pretty cool.
They're actually quite cool, because
they're not as weird as Trypanosaurs. But they are.
But that's only because
incredible.
actually they are weird, but we're just used to see them because they are well known in the fossil record. But if you think about it from our perspective, if we didn't know any fossils, and you think about it from our modern SquaMate point of view, they're super weird because no other SquaMates have gone that far.
That's true. That's true. And everybody forgets about them as SquaMates. I think that's like the big thing about Mosasaurs is that
they're not dinosaurs.
What's the largest reptile? What's the largest SquaMate? And then everybody cites anacondas and whatever, Titanoboa. And then they forget that there were these giant fuck-off aquatic lizards. True lizards. So, Gabriel, you're the fossil man. Let's get into it. What is a mosasaur?
Well, let's just start by saying, please, mosasaurs are not dinosaurs. So let's pick it up from there. Step one. They're actual
So what you're
SquaMates.
saying is that they're monitor lizards.
Well, no,
they're also snakes.
but they're closer to that. But what I'm saying is that because you hear it so often. I mean, people actually everybody says
they did. I know we're gonna get into the movie aspect later, but they fucking did it in this most recent Jurassic World movie. That I almost like yelled at the screen because they were like, "We need to go to the island and get DNA samples from 3 dinosaurs, 2 of which are not dinosaurs."
Oh God.
Yeah.
Oh,
a mosasaur, a pterosaur, and a sauropod.
Unacceptable. Unacceptable. Although I do get called pedantic when I tell people that pterosaurs are not dinosaurs. But anyway, I continue to fight the good fight. And we will continue to do so here.
Yeah.
But you can say, but it's actually worse saying that mosasaurs are dinosaurs because they're even farther away from dinosaurs than pterosaurs are.
Not an archosaur.
I think it's a good we should give a small, quick primer to listeners that are not super familiar with the tree of reptile evolution to say that within modern reptiles. Episode 1. Within modern reptiles, there are modern reptiles. We have 3 main branches, which are the turtles, which we don't know where they fit exactly in the tree, but they are definitely
We're pretty
not
confident
the other 2.
that they're closer to archosaurs than they are to the lepidosaurs.
Are you saying they're not diapsids.
No, that's what we're not going to get into that, but they are diapsids. They are diapsids. And then we have archosaurs, which include crocodilians and birds. Yes, birds are reptiles. And then we have lepidosaurs, which include tuataras and SquaMates, which, of course, as you know, includes lizards and snakes, so which are the same thing. They're all lizards. So mosasaurs are SquaMates. They are actual SquaMates. They're a group of SquaMates that went completely marine. So mosasaurs are a group of SquaMates that attained the biggest diversity during the latest part of the Cretaceous. And unfortunately, they were one of the groups that didn't survive into the modern age. They were right there on their peak of the diversity at the end when the giant meteorite finished
the one that no
everything.
one can pronounce.
Yeah,
Shishkalup. I've never heard it said aloud. I've only ever read it. I'm just like, I don't know what to do with those letters.
I'm not saying that I'm pronouncing it correctly. This is how
it's the one that had everybody have a very bad day for several.
Actually,
several
that was there's some just as an aside, there was some SquaMate news related to that recently with the Xanthuzia and lizards.
The night lizards, that they were one of the groups that were present already before the impact.
Yeah. Mine just gave birth. It's a parthenogenic. So.
Well, you have one. I didn't know you had one.
I did. Yeah, I do.
Of course he does. What was it like? Oh, of course he had to have one of each group.
Yes. Yeah.
Very cool. We don't have a
Pokemon
single. I think we don't have a single Xanthussid in our collection.
Well, one of the I should have saved it for you. I was going to say one of the babies was stillborn. I could have saved it for you, but
I don't think it would be feasible to get it out.
Like this way.
No.
Very cool.
Okay, so mosasaurs are, as a group, are adapted to a marine existence, but the earliest members of the group look very monitor lizard-like, although that doesn't mean that they're exactly closely related to them. Still, one of the things is that, like a lot of other things in phylogenetics, we don't know exactly. We're not exactly sure where mosasaurs fit. We do know that they are likely. First of all, they're toxicopherans, so they are part of the group
Venomous.
of SquaMates that include monitor lizards, iguanians, snakes, and anguimorphs, and all those. So it is possible.
So they are.
I think
to put that maybe a little bit into layman's terms, they are much more closely related to varanids than they are, for instance, to geckos, and
for sure
geckos being one of the oldest
for
groups,
sure.
And more closely related to varanids than skinks as well, if I remember correctly. So the Toxicophora is basically everything in the massive clade that doesn't include the skinks, the geckos, the dibamids, and a couple of other early.
I think it also doesn't include lacertids and tiaids.
Yes, exactly.
Like
yes, yeah, exactly. Yeah.
So, but within toxicopherans, their positions have been, it's controversial. Yeah, because they have been placed anywhere from the sister taxon to snakes to the sister taxons of the closely related to varanids. I think the current most recent research say that they are probably angimorphs, but it's not, super clear where they fit in that. But in any case,
so they're giant alligator lizards.
Well, angimorphs also include varanids.
Yeah.
Oh yeah. Okay.
Yeah.
So
it's a big clade.
It's a big clade. So
that makes me wonder if they shed their skin all in one piece.
I mean, there's definitely a possibility, but of course, there's like the shedding skin in one piece is something that comes and goes. So it's not like a guarantee just because they're members of the group. And it's certainly something that I would expect that a highly derived marine animal is going to kind of break away from. Also because you have assistance in the water to shed in.
Right. Yeah. So I'm just like that. My immediate first thought was like, oh, I wonder if that,
Yeah, I mean, it can tell us definitely, like the more we narrow down what the actual relationships are, the more it can tell us about what the real, like the ecology of these animals was like.
Yeah.
Yeah, and the reason why we haven't, figured that out is because, as you guys know, there is a lot of plasticity in several of the characters within SquaMates. SquaMates tend to do this a lot. So it's difficult because there's a lot of convergence.
And convergence
a lot of things.
misleads those methods. But maybe, Gabriel, the first place to start off with, I think some people are not familiar with what a mosasaur is or at all, right? So maybe at that level, can we get like a basic description? This is an ichthyosaur that is not an ichthyosaur.
No, actually, and I'm going to say that because this is a whole group, the first members of the group look very monitor lizard-like, with probably a few more adaptations to marine life. They probably had webbed feet and stuff like that, but they look very monitor lizard-like, very. From long, elongated skulls, triangular,
very
sharp teeth. As they evolved, apparently, several times they evolved marine. This didn't happen once. It happened several times. So they went marine several times within this group. And the earlier members of the group seem to have been live bears, which helped this going into the marine ecosystems.
And that is the reason we have no truly marine, true marine reptiles today, because we have no, with the exception possibly of some of the Acrocortus and other sea snakes, the true hydrophid sea snakes, which are live bearing. We indeed have, so turtles, for instance, are hard to call true marine because they still come on land to lay their eggs, and that's a difficult transition to make at the best of times. And it doesn't seem to just happen just because you want it to happen. So I mean, for turtles, it's a huge challenge, but overcoming that challenge is really hard.
So it appears that mosasaurs were already live bearers before they went to the sea, which helps. And
not super unusual, by the way, for the anglomorphs. I mean, for instance,
snakes are a bunch of snakes are live bearers. We have skinks that are live bearers. It's like a bunch of. It's not uncommon within SquaMates.
The night lizards that I just mentioned are live bearers.
Yeah. There is not uncommon within SquaMates. It's happened many times. So as they went into a marine existence and they adapted more to an aquatic lifestyle, they all separately in different groups achieved, their limbs transformed into flippers, very cetacean-like flippers, actually.
I've always thought of them as a lizard doing a whale impression, sort of a creature, like especially like the toothed whales.
Or I guess, exactly. Or like a huge shark. And their tails develop a bend at the last part of the tail that was in order to create a hypocercal fin on top of it. So they had like for all intents and purposes, a shark or a fish tail. They never lost their scales. And I say that because other groups of marine reptiles seem to have reduced the scales lost them completely or reduced them to very, very little. Even marine turtles, if you see like a leatherback, you can see they have very few like small scales.
And when they're juveniles, leatherbacks have neat little tiny scales all over the carapace. And as they grow up, they actually lose those scales completely, and it becomes a smooth carapace altogether.
Yep.
It's remarkable.
This seemed to have happened in ichthyosaurs, which lost scales, and plesiosaurs seem to have lost or gotten very, very tiny. So, unlike that, because they wanted to keep, their names as SquaMates, which means that Mosasaurs never lost their scales, and we know that because there are several specimens that have preserved scale impressions, and we know that they had actually overlapping, very small but keeled scales, especially on the dorsal
scales.
Yep.
What? That's very surprising.
Doesn't seem very hydrodynamic.
Yeah.
Well, it can be, but I mean, fish are, but notably not imbricated scales present in various members of the Anguimorpha. So,
but I think,
interesting.
Yeah, and then they have a lot of them presented keeled scales dorsally and smooth scales ventrally. Although I think that there are some that they have also found keeled scales ventrally, but
Mark, it was so that the Trypanosaurs could hang on as parasites.
Marine Trypanosaurs.
Yeah. Well, that's why they have a fin, you know.
Yeah.
A lot of this. We have never found actual evidence of life-bearing mosasaurs, but. And I say that because a few years ago, you guys remember there was this fossil that was discovered of a giant egg, and they say, it's a mosasaur egg, because it's very unlikely that's a mosasaur egg. It was most likely a dinosaur egg that somehow got, there. But and then we say that because we do have pregnant specimens of very early members of the group that seem to have been live bearers. That's why I said that they were live bearers when they were already very early members of the group. And also,
what do you think? Why do you think that would be the case as opposed to ichthyosaurs, where there are so many fossils of pregnant females?
It might be just a preservation bias, or where these things were, or
maybe also where they were reproducing. They might have been reproducing in the open ocean and less likely to fossilize, whereas the ichthyosaurs would be in shallow waters and more likely to.
That seems to be the case because we do have very, very, very early neonatal specimens in deep ocean formations. So that's how we know that they were probably live bearers, because it makes no sense that such a either unhatched or very early hatched specimen would have been in the deep ocean area. So it's very, very almost 100% likely they were live bearers.
Yeah, and depending on how quick they're growing as well. I mean, I'm just thinking of the leatherbacks, for instance, where the first instinct is go, and they don't really, they're riding currents as soon as they can from a tiny, tiny age. So they're not sticking around on reefs and getting bigger or whatever. They're also animals where I would imagine in the future, fossil record is going to show huge collections of juveniles that never made it out of the sand. But then you would probably also find the occasional teeny tiny juvenile in these deep sea sediment, because they are really they're going out as soon as possible. So maybe that's then we might expect to find mosasaur collections as well. But their bodies were also just extremely ill-suited to coming onto land.
It's impossible for them.
It's impossible. They would not have been able to locomote on the land at all. They would have beached in the same way that whales beach. So they had gotten to the point where this is not like a turtle. Like a turtle is built to beach because it can get in and it can get out. They've got incredibly strong forelimbs.
For many reasons, because if we're talking about the most derived members of the group, I wanted to say that the earlier members were, small animals around 1 to 2 meters long, but the most derived
1 to 2 meters. Small animals.
Well,
I myself am a small animal.
Compared to what they became, because the most derived, more marine mosasaurs were the largest SquaMates ever to exist. They reach length of well over 15 meters. So
15 meters with emphasis. 15 meters. Let's do it in feet. That's 45 feet.
And that is not a snake. That's an animal with a huge bulk, because
according to Jurassic World, they got over 100 meters long and 8 megalodons.
I mean,
So-
these are the most ludicrous of all SquaMates.
Yes.
I wanted to talk about something really quickly. There are two
We're good at really
characteristics.
quickly, yeah.
Yeah.
Yeah, there are two characteristics of soft tissue that we don't know, but that they're possible to likely. The likely one is that mosasaurs had a forked tongue because they are in a group that had a forked tongue, and there actually have been some studies saying that the forked tongue that they probably had was probably similar to that of helodermatids, so Gila monsters and like stuff like that. So which is a kind of a robust forked tongue.
Very.
But we don't know exactly what kind, but it likely had a forked tongue. And the other soft tissue thing that I wanted to mention is that there's a possibility that they also had a dorsal fin,
I was just going to say.
because this has evolved so many times in marine groups, and for in all other intents and purposes, they had animals with a hypocercal tail like that had probably a dorsal fin as well.
Can I go back to the soft tissue stuff for a second? I
Sure.
remember reading that we also have some pretty good evidence that they were counter shaded.
Yes.
Is that right?
Yep. A lot of it. Which I have a problem with that. With that.
I know you're going to bring this up. Yeah.
Because most animals are counter shaded.
Absolutely.
It really annoys me when it's like, oh, it was counter shaded. Yeah. Look at everything. It's counter shaded. More stuff is counter shaded.
I'd be more surprised if it wasn't. Yeah.
But
I would tell you
Yeah.
what, I won't put them on the internet for fear of people taking them. But the soles of your feet are also lighter colored than the tops of your feet. So
Yes, but I meant I'm talking about counter shaded in the way that like a great white is counter shaded or an orca is
but like
counter-shaded.
everything is like
Yeah.
so is a deer.
Yeah. So
And,
it's if you go outside and look at an anolis lizard, that's counter shaded.
Yeah.
So,
I guess it matters more in the water, right? That from what angle you're seeing.
It has to matter everywhere since everybody keeps doing it.
Yeah.
Okay.
Yeah.
So, but they do seem to have been dark. Like, so the only a few examples that we have melanosomes from, they do seem to have been very dark on top, and then, but this is very. We have little patches of skin. We
So
know
you're like duh.
they were. I would be surprised if they were black and white. I think that they would. You probably have patterns and stuff. So
Yeah.
The brown stripes.
Well, listen. Another thing, being in Toxicophora means that they could have probably been, have a venomous bite,
Yeah.
and I wouldn't be surprised if smaller examples of mosasaurs became highly venomous and had a coloration and a posematic coloration showing that I'm venomous. Don't mess up with me.
I'm wondering
smaller
too.
ones.
It makes because like in like the majority of monitor lizards and a lot of other lizards, the juveniles look much different pattern wise from the adults. So that you could have had like the ontogenetic change as it grows.
Oh,
But, like,
that is almost a given.
Yeah, I'm imagining like bold stripes as babies, and then
Yep, I actually did an illustration once of a nursery of mosasaurs where you have like a bunch of juveniles and the adult, and the juveniles are like boldly patterned because that's what happened in most reptiles. Like
yeah.
if you see a baby alligator and then you see the large alligator, baby alligators have those very
Yes.
Yeah.
Most monitor lizards that I can think of too, like the babies are
almost every reptile that you can think of is going to be like that.
Yeah.
fascinating.
So-
Definitely true.
So they were super well adapted. They probably didn't have an external ear opening, and it's probably because it would have helped to not have an external ear opening on the water. And there's a possibility that their nostrils closed as a valve, like in sea snakes. That would be also a big
You're
possibility.
saying they had a blowhole?
Well, you can infer that they would have had a lot of the modifications that we see in a lot of these animals. I mean, we know that the nostrils were not shifted far back on the head, but they are truly on top of the skull, right? And
some species have been quite far.
It's pretty far back,
not super far, but quite far. But so they were also all carnivorous. We don't have any examples of non-carnivorous mosasaurs. They were carnivorous, but their dentition did in some species change considerably because they were adapted to eating hard shell food. So there are some animals like globidens, which was a very large mosasaur that had the name implies a globidens. So it's like a bulbous kind of shaped teeth, which is not extremely unlike that of a caiman lizard. That help them crush
shells.
Prey. Probably from ammonites and stuff like that.
And those kinds of transitions can happen so incredibly fast in terms of the evolutionary speed. I mean, there are populations of orca today that have teeth for slicing, and there are populations that have teeth for crushing, and they're just, considered conspecific. And it changes depending on the diet. So they are actively adjusting kind of dentition shape. But then, of course, there are those sublineages, and that's within orcas today. So there's no question to me that they could have changed those. Those transitions could happen so fast in the fossil record time to go after different prey. And the prey that would have been around in the ocean would have been a little different from how it is today, but not dramatically. So
do you know if
kind of patterns?
Do you know if we have found fossils of shells being spat out or anything? Like crushed up?
We have fossils of ammonites with
punctures
that match the teeth of mosasaurs. We also have mosasaurs with matching teeth of other mosasaurs, which means that they were likely engaging into some pretty bad arguments.
That's a typical SquaMate thing too, though. That's
Yeah.
But unlike most SquaMates, I'm going to say something that is very interesting, is that it seems that mosasaurs were endothermic. There has been some studies that hypothesize or show robust hypotheses that mosasaurs had a kind of a metabolism that is more similar to modern birds, and they were able
leatherbacks are also true endotherms. So at least when they get above their relatively small size,
it's another kind of a necessity when you're a marine animal, right?
Exactly. It comes as no surprise.
Does that imply
especially because
that
we know mosasaurs from around the world. Like we have mosasaurs we have fossil mosasaurs from all the oceans, so they would have been truly be worldwide in distribution.
That's where I was going with that. Is I was going to ask, do we have evidence of them being in colder environments?
Yeah.
Yep. Yeah. There are some beavers that have, and it's not the first reptile group that does that. We also have ichthyosaurs and plesiosaurs from those areas, but unlike turtles, which are
I hear there's a plesiosaur in Scotland.
Don't bring cryptozoologists into this podcast, please. This is one of my least favorite group of people.
About that. We'll refer you over to Darren over at Tetsu. Yeah. You can go and talk with him about your cryptids.
Yes. Yeah.
How many species have been described?
Oh, that I don't know the exact number, but there's a ton of probably well over 40, 50 species.
I would note that they're not in the reptile database. So, which catalogs only extant species, of course.
And how would I take care of one in captivity?
You need a very large. Well, it depends on the species that you want. You can have so for you guys that saw Prehistoric Planet, you saw this small mosasaur that I reconstructed for the series. Yeah. You could have that in no, you still need kind of a large tank. You need a very large tank for even the smaller ones. But for the large ones, I don't think you would need. I don't think you could have one because they would be larger than an orca.
Yeah.
Yeah.
So, would you be feeding it great white sharks as they do in the 20
hanging from a thing like in the
I think that's actually a really good place for us to pause. We'll come back after a short break, and we're going to get into a little bit of the presence of mosasaurs in the media, in televised content, etc. And I think you'll find them to be more widespread than you thought. More on that in just a minute or a second. Come back after this musical interlude. Dun, 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 dun. Okay, and we're back. So, actually, before we get into the media stuff, we had some other things that we wanted to talk about. So, Gabriel, you wanted to talk about skeletal features and some kinesis, right?
Yes. So mosasaurs had flexible skulls like snakes do. They also have double hinge jaws, which means that they were able to swallow prey that was potentially larger than what they would have normally, that another animal with that size of skull would have been able to. So that means that we know for sure that a lot of species ate a lot of other stuff. We know that the remains of them eating giant diving birds like Hesperornis, a bunch of fish, sharks, and even smaller species of mosasaurs or even their own kind. So they were cannibalistic. So I just wanted to put that there. And
yeah, I mean, it kind of makes sense given the group that they belong to. They have a very highly hinged jaw. The gape even of monitor lizards today is surprisingly large. And of course, that's not to mention the macrostomy approaches that various snake lineages have taken. So there's it kind of makes sense. They would have had a crazy jaw gape, especially in comparison to mammals of similar size or fishes of similar size, fish in the broad sense, of course. So yeah, and then the other thing we haven't mentioned so far is the age, right? So these are all in the Cretaceous-y end Cretaceous-y period, which
they appear in the late Cretaceous and they disappear in the late Cretaceous, but it's because
which
the
is
late Cretaceous is a huge.
Boom. And so what do you think made the opportunity for them to kind of explore that space? Was there a loss of ichthyosaurs around that time? What were the sharks doing at the time? Like, what is the
they coincided with the last part of the ichthyosaurs, but there were plenty of plesiosaurs, both short-necked and long-necks, and they stay with them until the end because plesiosaurs also disappear at the end of.
Either no real competition because sufficient resources for all, or niche partitioning.
I think the key is also that during the late Cretaceous there were a lot of shallow seas, and that also that entices animals to go into the water, and so there are a lot of more groups trying to exploit those niches. So. I think for sure that's one of because I know during the Triassic, a lot of animals go into the sea also, and there were also a lot of shallow seas at the time. So it's possible that has something to do with it.
Mm-hmm. Yeah, and we know, of course, if some of them were specialized to feed on ammonites were a group that were completely wiped out in the Cretaceous, the end Cretaceous event, and then. I guess many of these things were really, really heavily hit by the end Cretaceous events. And then I guess whales made it onto the scene. They took advantage of the stuff that was happening in the Neotethys at that time, which was largely somehow protected from, because that's where whales were getting their start over there in what is now India.
It's crazy to think that with so many fish and both bony fishes and sharks and stuff already using that, you would think already using that niche.
Yeah.
Tetrapods feel the need of always going back to the sea.
Yeah, it's we're just like the elves from Tolkien, constantly pulled to the sea.
I about once a day want to walk into the sea. So
So it coincides with you opening the news apps, right? I too want to return to my fishy forebear. Anyway, right, let's get into it. Now, I want to contend something. I want to contend that there is a more famous mosasaur than the ones from Jurassic World.
okay.
Mm-hmm.
The magical Leopleurodon, Charlie.
I don't know that more people saw Charlie the Unicorn. Yeah.
But that's not a mosasaur.
Wait. Leopleurodon's not a mosasaur?
Leopleurodon is a plesiosaur.
Oh,
I've been had.
Get out.
All right, I'll leave. You guys take over from here. Bye-bye. How do you tell them apart?
It's a short neck plesiosaur. It's a plesiosaur, which are short neck, or most of them are short.
I forgot about plesiosaurs.
Most of them are short neck plesiosaurs.
Plesiosaurs. Pliosaurs. Plesiosaurs. Stop it.
Pliosaurs are plesiosaurs.
But not all plesiosaurs are pliosaurs.
We need to have words.
Exactly.
Yeah.
Unacceptable. All right, then I retract my point. It's totally irrelevant. I'll cut this bit. The most famous.
I don't think you were right. I don't think you were barking up the right tree anyway, because I'm pretty sure more people saw Jurassic World than Charlie the Unicorn.
That may be true.
Yeah.
Although Charlie the Unicorn? Charlie the Unicorn was a very important part of my 2007 internet, 2008
early internet,
early internet experiences. Anyway, right, Jurassic World. It's basically the only one. I mean, they do feature in our the one that Gabriel was involved in.
Well, they're in the Crystal
Prehistoric
Palace. They go back. Aren't there mosasaurs in Crystal Palace, or are those plesiosaurs too?
They're plesiosaurs. And ichthyosaurs.
And ichthyosaurs. Okay, so no mosasaurs there. Yeah, I think you'd be hard pressed to find too many others. I mean, I remember having like toys of even pre-Jurassic Park, like having toys.
Yeah, because they're well known. I mean, the United States has a ton of mosasaurs because they all lived in the interior seaway, but a bunch of them live in the interior seaway. But so there's a bunch of fossils from here, but. In the movies, like in the media, like in the popular media, the first I think that really made such a huge impact is the monstrosity of Jurassic World.
There was one in one of the.
I'm happy to report that I've never seen fully. Like I've never been to see one of these movies. I've only seen the original Jurassic World, and like Jurassic World 2 and 3. I think those are the only ones I went to see in the theater. But I've never seen Jurassic Park. Yeah, sorry. See, this is the problem with the stupid movie.
You don't want to confuse those two things.
I went a couple weeks ago. I went and saw the new one, and so you don't have to. So you don't have to, and it was like maybe plus 1,000 points for not having Chris Pratt in it, but then like minus 1,000,000 for everything else. It was not good, and my family has made fun of me for going to see it, making them go to see it since then, because they were like, I can't remember a single character's name, and it made me angry. Like when they're like with the thing with we're gonna go get 3 dinosaurs, and 2 of those are not dinosaurs. So it was bad. It has Scarlett Johansson in it. I can say that much. That's about. I guess I would move that to the positive column, but then everything else was like awful.
I moved to the positive column, and that it has Jonathan Bailey. That's it.
Right.
But that's why people probably went to go watch it, right?
Yeah,
and that's why it's so annoying that they don't put the science and make it accurate. And here you have a chance to. You've got the people coming.
But isn't this part of the whole current movement to move away from what the scientists are saying? Like, don't you want to explicitly reject the science? The dinosaurs can't be feathered because then the scientists win.
Yeah.
No.
Oh no! So you can trust the dinosaur, them to give it a name, almost. The scientists can give it a name. They can give you a vague idea of what it could look like, and then it's only creature designers and.
But in this movie, they're not even. Allowed. They're almost most of them are not even real. I mean, they're not even based on. They're actually modified to be characters.
They have this shit with mutants and stuff, and it's really boring. Yeah. I read a really good article this week about the movie Nope, which is one of my favorite favorite horror movies of the last 10 years, about the creature design in Nope. And I won't spoil Nope for you. It's Jordan Peele. It's
excellent.
It's very good, and the creature design in it particularly is very, like, it's always great when you get an alien in a movie that feels alien. And it's so alien, you're not even sure it's actually an alien. And the article was about how you have this spectrum of naturalism in your monster movies, from 100% monster, like a xenomorph, right? In the alien movies, versus animals doing natural behaviors. And Grant in the first Jurassic Park even says they're not monsters, they're animals.
All right.
Really driving it home. I think every Jurassic Park movie since the original has gotten that wrong. And that's why the original is so much better. Is it grounds these in reality as animals. And yes, there are movie monster elements. I think you could definitely argue the velociraptors chasing them and screaming at them and stuff are not realistic, but it tries a lot more to get naturalism than any of these other movies do. And there's maybe like one scene in this new one where they're watching sauropods kind of do courtship, but they edit out the fact that it's supposed to be courtship. They're just like nuzzling for no reason. Like, show me sauropods fucking, and we'll have a discussion. But anyway,
but it has to be all of the monsterification without any of the of the nature, any of the
And the thing I think also that has just annoyed the shit out of me with these movies is they're more about nostalgia for 1993's movie than anything else, right? So that's why we get the original cast back in the previous one, and like it's just nostalgia baiting stuff. It's not, it understands nothing about what made that movie great.
Yes, it is an attempt at following the commercial, what they interpreted to be the commercial appeal of the film, and I don't know how big a flop it has been, because we have different standards than them. But like at some point, you can just stop pretending. Like you don't have to. It doesn't have to be.
People keep bringing it. Well, you're a nerd. You're just into it for the dinosaurs, and you want accurate dinosaurs because you're a nerd. No, I would argue that what made the original work was trying for maybe not always getting there, but trying for accuracy, which grounds it in reality, which in turn then actually makes it scarier.
Well, not only that, but there is a pivotal scene in the first movie in Jurassic World, the original one, which was the one that I will always remember. Jurassic Park, which is the one that I will always remember. Is the one that really got me. Which is the one where they see the Brachiosaurus walking, and they are marveled by the how amazing these animals are. This is what's missing on all these movies. There's not a moment of marveling at these amazing creatures,
because no one else is Spielberg. Nobody else gets that sense of wonder right. Spielberg does it. Spielberg, that's his like bread and butter, right? He knows how to do that. Everything else is a pale imitation of what even Spielberg himself. Doing the sequel, it's a pale imitation of where he got with that sense of wonder and awe. I 100% agree with you.
And I'm gonna say because I'm a concept artist and I know this from experience. This has nothing to do with the concept artist. Concept artists and artists try to push really interesting designs. Most of the time, I would say almost every single time, and you are denied and told to change it to stupid things. I've been told even to stuff like, I shouldn't. I'm not gonna say, but tell stuff that you're like, really, you're telling me to do this, and it's like
you're making it worse. Yeah. Well, we get in this most recent one, we get a mutant dinosaur. In between all the product placement, we get a mutant Tyrannosaur D-Rex, Distortus Rex
which
monster. That it's not even a good monster design.
Horrible.
It's a
That's
Rancor.
Also not how Genera work.
No.
No, it's a Rancor ripoff, basically.
But let's save the terror part of all of the Jurassic World franchise. We're almost finished, I guess. So, it's just not good. Stop it. Go back to wonder, childish wonder.
Just stop making these movies
because we're not supposed to be doing this thing. Let's try again. Let's do other things, different
ways.
Go
make something else.
Have created dinosaurs again. It's all it's cool to do Jurassic or most of the things in the films are anyway Cretaceous. But let's do Cretaceous Park or a totally different thing that has kind of similar premise because it can be cool.
Yeah.
But then stop making things just complete because it's as if there isn't enough drama in the real world, which very, very many existence of real nature documentaries totally flies in the face.
Well, just constantly going to the we made mutants monsters. Yeah. That to me suggests a lack
it's a very
of
human circle jerk.
Yeah.
We are in charge and we are the best at making things worst.
I was going to say it suggests a lack of interest in your subject matter too, because there are so many dinosaurs you could have chosen.
The whole movie is about that. I mean, the problem with this last movie apparently is that the person that ended up directing it and didn't even like the subject, because the movie starts. The premise is that people have gotten bored in this world with dinosaurs. Right. They don't like dinosaurs anymore. They got bored with them.
Yes,
you know that, right, Mark? The premise of this movie is that people, we've been having dinosaurs too long. We don't want to because
never mind that they've been popular since the Victorian era. Basically,
not only that, people don't get bored of animals. That's why we still have zoos, and people flock to fucking zoos to see animals make lines and stuff. So it's just stupid. Even my cat is complaining.
Also shares your opinion. It's finally weighing in. What is this? Someone's upsetting my humor.
So I will curb the Jurassic World hate, but I do want to point out, and I shared some graphics that some folks on the internet have made about the relative sizes of the mosasaurs in these movies, and they get bigger every Jurassic World. They start out not basically even the one in the first Jurassic World from 2015 is
3 times bigger than it should be.
Is 3 times. It's basically 2/3 the size of a blue whale.
No, it is 1.5 times the size of a blue whale.
1.5. Okay.
Yeah,
it's huge.
It's
enormous.
Huge. It is obscenely large. These animals were about half the size of a blue whale. They were big, but they were not blue whale big.
Right.
And it would have been. I don't think that's even functional, right? Like an animal that size.
Probably not. Yeah. But by the end, in this most recent one, it's basically it gets to be about 2.5 times the size of a blue whale. It's ridiculous. It's eating Spinosaurs.
Obscene. Spinosaurs were big dinosaurs.
And they make the Spinosaurs look like little guys.
Spinosaurs swimming in the sea. Ugh. I just can't. It's too much.
Let's talk about.
Yeah. Well, okay. All right. I was going to say that they went they made their own Spinosaur designs shittier because the Jurassic Park 3 one from 20 years ago was way better looking than the 2025 Spinosaurs. Anyway,
that's not good. We didn't hear what you just said, Hiral.
I said it's a mutant.
Yeah. You can basically fall back on that excuse no matter what. So
what was the last movie from the franchise that you saw, Hiral?
Oh, I watched this last one.
Oh, you did? Oh,
I did.
How could you
That's
stomach
why
it?
I know how bad it was. It's ridiculous.
Yeah. Did you also want to scream at the screen when they were like, we need 3 dinosaurs, and then 2 of them were not dinosaurs?
Yeah.
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 And the we haven't even talked about how bad the Quetzalcoatlus is in it.
It's a Mosasaur episode.
I know.
Get those non-SquaMate creatures out of here. We should be talking about this.
Yeah, but As Darkins would make a great movie monster anyway.
For sure. Absolutely.
And you fucked it up.
Yeah. In Berlin, they have a life-size Asdarkid model at the zoo, and it's really cool. It's like, that's a remarkable creature.
Basically, what if a giraffe could stab you and fly?
For sure. Yeah. But I would argue that Mosasaurs, brief though their time was, may be one of the most deviant of all SquaMate lineages that we know of, right? Such an exceptional group of SquaMates. We have nothing doing anything like it today. We have plenty of aquatic lizards, but we do not have any lizards that are seagoing. Other than marine iguanas, which, but like,
well, they do it better than any other one, though.
Certainly, no question. But there are monitor lizards that are almost or equally good swimmers. Water monitors, for instance.
But iguanas have salt glands and everything.
That led me just immediately. I was like, do you think Mosasaurs sneezed salt out like iguanas?
I think we have evidence of salt glands, so they probably it wouldn't be surprising to me if they surfaced and then went down.
Yeah.
That's a cool thought.
What they basically had to. I guess they might have also done some oxygen exchange over their cloaca,
turtle style.
Style. There's all kinds of fun things that you could do when you've got like that. But I think that they are such an interesting group, and although we have plenty of aquatic lizards today, we have no lizards with flippers, none. And this is a group that very quickly, the period that they were around for was about 30 million years. So in the space of about 30 million years, you went from something that looks like a monitor lizard to being, first of all, fucking gigantic, and secondly, having these massive flippers, front and back flippers, by the way.
Are you asking how can we dire wolf this situation? Is that what you're getting at?
Extremely not. Please do not support or suggest.
I took this caiman lizard and I gave it flippers.
SquaMates haven't gone to the sea that often either. SquaMates and Lepidosaurs in general, because it did once in Tuataras. Tuataras did it once.
Yes.
They got close, but not as bad as Mosasaurs, but they got close to something.
It's actually a really good point. We haven't really talked about, but there is this whole lineage of the Sphenodontia that were also big marine reptiles.
Could the live birth be the limiting factor, or the non-limiting, the having to lay eggs?
I don't think so, because there are so many groups of SquaMates that do it. That already are life-bearing
in SquaMates. It just changes so fast. There are species of skink where some populations give.
I was just going to say that
populations lay eggs.
Right. Yeah, I was going to say.
It's not as big a switch as people have often claimed it to be, but it's like the chameleon thing. So let's go back 2 episodes. It's just like chameleons. It's the right combination of features that are predestining this group to be
at the right
unique
time,
in a way. At the right time, the opportunity in the seas. It's not to say that it can't happen again, but at the time, it was just, there was ripe opportunity, lots of seas, lots of warm, shallow seas that would have been excellent for kind of moving into this space. And then just the right combination of features. You have a hypermobile skull. You potentially have venom. You're big, sharp teeth. You're already many, especially monitors, but many other groups of lizards as well are extremely good divers as well as just shallow swimmers. So you've got that really good combination of features, and then just opportunity and chance.
I was going to say Galapagos marine iguanas didn't get their on land, they got their swimming, and green iguanas are excellent swimmers. I see it on the bay, on seawater, on the bay. I see them going there like diving. So it's not, they're good swimmers.
I think we've actually had this discussion once before where we talked about what lizard potentially would make the next Mosasaurus. And I think for me, I think iguanas are a better contender than modern day monitor lizards are because they spend more time in and around marine habitats, I think. Although you do have like mangrove monitors and stuff like that. So I guess,
Yeah, I mean, and water monitors, which are not super
the
far.
thing is that
many of them are not eating fish.
The thing is not so much which one, but would they be able to exploit a niche? Because we have cetaceans now, and we also still have sharks. So
not if human beings have anything to say about it.
The real niche would be the one that is the marine iguanas are exploding because they're herbivores, and they're feeding on algae. So the only other thing that we're eating that we have in herbivores in the sea is manatees.
Mm-hmm.
So I think
it's a big
that's
opportunity. Well, other than the turtles, of course, sea turtles, but I do think that there is a big, a major limitation for. I mean, marine iguanas could do so much if they weren't stuck at one of the coldest seas around. Like there would be so many opportunities if they were in a warm place and they could just go gently toward endothermy, but they can't. Maybe they can figure out gigantothermy because what they're doing is they're freezing in water until they come up and
but the real question is why are iguanas in warmer places not doing that?
Yeah.
Yeah, but that's just opportunity. That's just or chance. I should say chance.
No, the real reason I think is because marine iguanas have poor food choices on these islands. They had to exploit it. So in the other parts, probably they have much more options to like in the northern coast of South America, iguanas are probably like, I'm not going in the water. I have all this fruit over here. Why am I doing that?
I could eat out of freezing cold water.
I could eat out of everyone's. I was going to say they could eat out of everyone's trash bins, basically.
True. But to be fair, also, like Amblyrhynchus weren't the only iguana. They diverged from the pink land iguana on the island, which doesn't go into the sea. So like it wasn't by necessity, let's say. It was just like some of them decided to eat water plants and moved in that direction. So I think, if you could fast forward the clock a few million years, there might be some really, really interesting stuff happening there if the islands would stay above the water long enough. But they can move between the islands fairly well. So, that's going for them for sure. So, fingers crossed that we get another Mosasaur-like thing in the future. But it is a damn shame that we don't have them today. And it's such a classic case, I think, from an academic perspective, it's such an interesting group. Huge, fairly diverse lineage, fossils all over the world. We've got mosasaur teeth in Denmark as well. Like we've got fossils absolutely everywhere, and then a blip of appearance, kind of. And we cannot, even though we've got good skeletons and everything, the level of plesiomorphy in these stupid lizards has led to the fact that we can't place them in the tree. And it just is so infuriating because this is such a major group of lizards. And that's all they are. They're just lizards. And yet we have no idea what their real relationships are. It drives me absolutely mad that this is a group that we like. It's going to be a long time before we figure out exactly
if we can't even figure out where turtles go, I mean...
Yeah, but turtles is so much longer ago, and we have beautiful in-between fossils for turtles. We don't have the early ones that really answer the question, but we know how turtle shells evolved really well. But what we do not have is like we even have early dinosaurs.
I'm just saying we have a lot
early enough to know which of the branches in this stupid tree they were diverging from, and things.
I think even if we have the early ones, the super early ones, there's still so much convergence in so many characters within SquaMates, so much plasticity.
Insane.
It's very
difficult.
difficult.
You got to find those characters that you can put huge weight onto, or build your tree only on those characters so that they don't mislead everything, but which ones are informative and which ones aren't. So then you have to build huge character matrices, and this is why I only work in molecular.
We need to find a mosquito that bit a mosasaur that was surfacing and was preserved in amber, and somehow the genetic material got preserved, and then we.
Hey Gabriel, where can one find you on the internet?
Okay, so are we saying that now? Are we finishing here?
I think so.
Okay, so yeah.
Do you have anything last to say? Any final words? Any
it's
last words about Mosasaurs?
I am at Serpent Illus on Instagram, on Twitter, on Blue Sky, and my website is gabrielughetto.com.
And Universal, hire him to design, to concept art the next.
They did hire me, but for another project.
Well, to be fair, we didn't talk about any of the good examples, but that doesn't matter. The music's already playing. Ethan, where can one find you on the internet?
I'm at my website is ethankosak.com. Everything's linked off of there.
Excellent. Hiral, how about you?
I'm at Hiral5 on Instagram and at HiralKnight everywhere else.
You can find me at Mark Scherz, MarkScherz, all over the internet. You can follow the podcast at SquaMates Pod on all the things. And you can watch these episodes over on YouTube, youtube.com/@SquaMatesPod. You can send us email at squamatespod@gmail.com. You can go to the website. You can find show notes there. You can also find links from there to various different places where you can listen to the show. But of course, you're listening to the show, so it's kind of redundant that I say that. And anyway, as we usually and often and always say on the show, Hakuna
Squama.